Hello, kiddos.
Welcome back.
All right, so this video is going to be on infinite limits, graphical. This should help you out with the first assignment from week 2, lesson 1. Again, infinite limits, graphical. I'm gonna go through a Khan Academy example, but before I do that, let's quickly do a reminder. You need to know about these things called vertical asymptotes. Asymptotes. This is an imaginary boundary that your graph will never cross. And since we're doing infinite limits, you'll notice that vertical asymptotes are going to pop up a lot. How do you get a vertical asymptote? Let's say you have something like this. 3 over x minus 4. Like this is a function. F of x equals 3 over x minus 4. Now, what happens if we plugged in 4 for x? So we plugged in a 4 right here for x. You get 3 over 4 minus 4. So it'll be 4 minus 4. Well, what's 4 minus 4? Good, 0. You get 3 over 0. What is wrong with this? You can never have a 0 in the denominator. You cannot divide by 0. That's a big
No.
All right, so what does that mean? For a graph, that means if you try to graph this function right here, when you get to the point 1, 2, 3, 4, so when x is 4, you have a vertical asymptote, just like this. And your graph will never cross it. Never, ever, ever, ever. Which means it could do something like this. Oops. Cross. Well, you know what I mean. It could do something like this where it gets very close, but before it gets to it, it starts going up. So it approaches the point x equals 4, or it can approach it and go down, but it'll never actually cross it. Okay, so with that in mind, let's look at our first example. From Khan Academy, it says, consider graphs A, B, and C. The dashed lines represent asymptotes. All right, which graphs agree with this statement? So it says the limit of f of x as x approaches 0 from the right is equal to infinity. So I'm gonna look at these graphs and I'm gonna see which one of these graphs represent this right here, reflect this right here. So as I approach 0 from the right, my graph should be heading towards infinity. Let's check the first one out. A. I'm gonna rewrite it right here so we can look at it the whole time. So it's the limit of f of x as x approaches 0 from the right is equal to positive infinity. Okay, so here's my graph. I'm interested at 0, so that's going to be right here when x is 0. This line right here, the y-axis. Now, as I approach 0 from the right, so what happens? I should go up to infinity. But if I look at this one, as I approach 0 from the right, I actually get, I don't know what that looks like, negative 1/2. Nope, that's not infinity. So I know it's not A. Let's check B. Again, as I approach 0 from the right, I need to be heading towards positive infinity. So again, here's my y-axis, which is 0, x is 0. As I approach 0 from the right, ooh, that looks good, except it's going down. That's towards negative infinity. We want positive infinity. But it gives you an idea of what should happen, right? It gets closer to the line, but instead of going down, we should be going up. So I know it's not B. C. All right, as I approach 0 from the right. So here's 0 again. As I get closer to it from the right, what happens? Oh look, it's starting to go up. So it approaches this vertical asymptote, but keeps going up, 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 up to infinity. I'm gonna click C. So let's click C. And let's check our work. Oh golly, we got it right. Cut.